I've created an example called Simple Grid, which uses the event-driven programming model that we've just been talking about. It applies it to the same kind of grid we've been using in our simulation and as you saw on Code Academy in the Battleship project. But I've made a very, very simple version of it. So let's take a look. First of all, I took the system that we wrote and I put it in a separate file called system, just to pull it out because really that's not part of our program. Here's our program, Simple Grid. I said from system import star, that gives us access to the system. Let's start by looking at the body of the program, and you'll see the whole thing is not very long. This is it. Again, we start with our constructor, and it has one key variable that represents our system, which is the location of me, the creature. The grid is implied of just a fixed grid that is n by n cells specified by a variable called dim. Then we go ahead and make an instance of our system and add a callback, which is this callback, a reference to this method right here. The callback, which we're going to wait just a minute till we see exactly how it works, basically is going to figure out what the user typed in and then call the move method with an amount to move. And then the move method is going to take the amount that was moved and move me that amount. You'll notice the callback method also prints self, and so I've defined a description string method that prints out a pretty version of itself. Finally, the whole thing runs with this simple startup code. We make an instance of Simple Grid, we print out the grid just to see where it is when we start, and then we call the main loop. And that's it. And the main loop takes care of input and calling our callback. Let's start by seeing how it works. When I run the program, it prints out a 5 by 5 grid and it shows that me is at the middle at the location 2, 2. And I can type in left, right, up, or down. If I type in left, it goes left. If I type in up, it goes up. If I type in up again, it goes up. If I go right, it goes right, and so on, until finally I get bored, I can type in quit, and the program terminates. So now let's dive in and see how we implemented this movement, because we actually used two new little tricks. First of all, actually 3 little tricks. The first thing is that we've declared what is called a member variable. So far in our classes, our variables have all been instance variables like self.me, and you get an instance of me for each instance of the simple grid that you create. And that's what we've wanted so far. But there are other times when you don't need a copy of the variable for every single instance. Like when you have constants, you don't need a different version of the constant for each instance. Instead, it makes perfect sense to define that constant once for the class. And every instance accesses that same constant. And so the way you do that is you define your variables inside of the class, but outside of any method definition, and you don't use self. So in Simple Grid, we define the variable dim to be 5, and direction deltas to be a dictionary. Alright, so here is the second trick. We want to take the input that the user types, which is left, right, up, or down, and then move a certain amount. So how much do we have to move? And how are we going to figure out which direction they've moved? Well, when I first started writing this program, I thought I would just have 4 if statements or elif statements. If input is left, then move to the left. Else if input is right, move to the right, and so on. That's fine, but that put a lot of code and logic that potentially could be buggy, when really we were doing the same kind of thing over and over again. And so instead, what I decided to do is define a dictionary where the keys are the inputs that a user can type, left, right, up, and down, and the values are a list with how much to move. So if the person types in left, then we should look up its value and see that they should move 0 rows and -1 columns. That means to the left, and so on. So let's see how that works. When we look at our callback code, we get our input, which is the event. That's just the word that the person typed in. The first thing we have to do is make sure that event is in our dictionary, because a person can type in anything they want, and they might type in a word that's not left, right, up, or down, in which case you would actually get an error. So only if they type in a valid direction, then we get the value associated with that key, right? Here's the dictionary, and we just access the value by putting in the key. And I'm going to store that value in a temporary variable called delta. And now I'm going to call the move method with that delta. All right, that was new thing number 2. Let's look at the move method. Move method takes delta, and it just figures out the new row and column. This is very straightforward. It takes the row from me and adds it to the row amount of delta, because those were both the first items of the list, and then it does the same thing for the column, which comes from the second item on the list. So we've got the new row and new column, but I want to make sure that the person has stayed in the grid. If they're on the right column and they go to the right, I don't want them to go past the right edge. And so I want to make sure that the new row is valid. That means that it's between 0 and the maximum dimension. So again, this is the third new thing. I first started writing this by having 4 conditions. If new row is not too small, and new row is not too big, and new col is not too small, and new col is not too big, then go ahead and move. And actually PyCharm gave me a little hint, and it said you can actually combine the 2 new row comparisons with this clever trick. You can say if 0 is less or equal to new row is less or equal to simple grid.dim. And this seems kind of strange, but this gets evaluated in just the same things we already know. Just a nice, clever way of combining some conditions. So if this succeeds, then it updates the position of me, and that's what the move method does. And that's it. That's our whole program. And again, this is an event-driven program because we structured it with a callback. And the program doesn't do anything unless the system decides an event has come in and it's time to pass control temporarily to your call.